We have come to the end of our laws of exponents unit. And so now we have a nice little review that we would like to present to you. And after that, I think we'll be about ready to take a test. So let's see how this goes. So first of all, when we learned about exponents, the first property that we learned about was multiplying powers. And so the principles that go with that was when multiplying powers with the same base, add your exponents. And if there happens to be a coefficient in front, you multiply those together as well. So let's go ahead and do this first one. We've got 2 times 2, which is, so 2 times 2, and I'm kind of grouping the coefficients together. And then k to the fourth, and k to the second. So 2 times 2 is 4, and on our k, we've got 4 plus 2, we add the exponents, that would be to the 6th power, and there we go. And we did quite a few different examples like these. Some had multiple parts, but that's the basic idea. All right, then we talked about when you raise a power to another power, you multiply the powers together. So here in these parentheses, we have a couple of powers. We have 4 to the first, we have x to the second, y to the second, and we're raising all of that to the 3rd power. So if we multiply that power that's on the outside, that 3, we multiply it by each exponent on the inside. And one of the mistakes that most people make, when they do make a mistake, is they don't multiply that power to this power on any constant out front that's got a 1 on it for an exponent, so we can't forget that. So if we do that, we end up with 4 to the 3rd, x to the 6th, and y to the 6th. And in some cases, if we're asking you to simplify this all the way down, we would want to know what 4 to the 3rd is. And so 4 times 4 is 16. 4 times 16 would be 64. So 64 x to the 6th, y to the 6th, that would be completely done and simplified. Okay, so when you raise a product to the power, you give the power to everything in the parentheses and then simplify. All right, so here's one. Remember this, if we have a variable by itself that has no visible exponent on it, we just put a 1 on there. And then we multiply this by each exponent on the inside. So 4 times 1, 4 times 4, and 4 times 4. That's going to give us m to the 4th, n to the 16th, and p to the 16th. These bases are all different, so that's really as far as we can simplify this particular expression. All right, then we talked about when you're dividing powers with the same base, subtract the exponents, take them where they will stay positive, up or down. So kind of an interesting prospect there. Now this problem actually has a couple of different parts. We got a 2 over 3, or excuse me, a 3 over 2. So as part of our answer, we've got 3 on top and 2 on the bottom because that's already simplified. Then as far as our ends are concerned, we got 2 on the top, 2 on the bottom. So they're the same. So if we actually subtract that 2 off of the top and the bottom to try and move 1 up to the top, we end up with n to the 0 power, which equals 1. So the ends really just cancel each other out. And we're left with m to the 3rd on the bottom. Another way to look at this is you've got the same thing on the top and the bottom as far as n squared is concerned. Anything divided by itself equals 1. So that would be that. The next property we talked about was the zero exponent property. And we mentioned that anything raised to the power of 0 except 0 is equal to 1. So if we look at this big expression, we might be intimidated by it. But we look out here and we notice, hey, that whole thing is raised to the 0 power. Well, if that's the case, then anything raised to the 0 power equals 1. So we can replace all of that with 1. And then on the bottom we have 2x y to the fourth. And none of those are 0 or negative or anything like that, so we don't have to do any further simplifying. That's already simplified. So let's try it. Let's get a negative exponent positive, move the power across the fraction bar. So if we notice, we've got this particular expression here, and these two are negative. So if we look at this whole thing, we think of this as 4u to the negative 1, v to the negative 4 over 1. And we look at these two and we say, hey, if we can move those across the fraction bar, we can change those to positive exponents. So if we do that, we end up with 4 left on top, and u to the first, v to the fourth on the bottom. And then if we multiply that by 2, u to the fourth, v to the third, what's that going to look like? So 4 times 2 is 8. And then on the top we have u to the fourth, v to the third. And on the bottom we have u to the first, v to the fourth. And so we mentioned earlier that when you divide exponents with the same base, you subtract the smaller exponent from the bigger one, whether it be on the bottom or the top. So on this one, we've got a u to the first on the bottom and a u to the fourth on the top. So we're going to take that 1 up and subtract it from the top, canceling it off of here. So that's going to leave us with 8 u to the third power on top. Now how about the v's? We have 3 on top, 4 on the bottom, so we're going to take that 3 down and subtract it from the bottom. So 4 minus 3 is 1, so we end up with v to the first power. So we simplified that using the laws of negative exponents as well as a couple of other properties. So we've got a nice worksheet, the All Exponents Review worksheet, and it's got a number of problems that look a lot like this. So we thought we'd work through a couple of problems so that get you a jump start on the worksheet. So what I like to do when I'm doing a problem that's got multiple parts is kind of separate it out so that all the parts that are alike are together. So we got our constants, we got our x's, and we've got our y values. So let's simplify each part. So 4 divided by 4 equals 1. So those 4's actually reduced to 1. The x's, we take the x on top, which is smaller than this 3 down here, subtract it from the bottom. So we end up with x to the 3 minus 2, which is x to the first power. On our y values, we do the same thing. We take the 3 off the top and the bottom, or we bring this 3 down and subtract it from the 4, and we end up with y to the first. So fully simplified, this is just 1 over x, y. And I think you'll agree, if you look at what it was originally and what it's simplified to be, it is much more simple looking than the original problem. All right, let's take a look at this one. we'll kind of keep that same process in mind. We got 4 over 2 out front, and then we have an a of -3. There's no a's on the bottom just yet. And we have b to the third on top and b to the third on the bottom. So 4 over 2 is just equal to 2, right? Because 4 divided by 2 is 2. And then as far as the b's are concerned, well, we'll go with the a first. We have an a to the -3rd power. And we know from the negative exponent property that we can move that to the denominator. And that will become a to the 3rd power in the denominator. Then our b to the 3rd powers are equal to each other, so they actually cancel each other out. They simplify to 1. So our final answer is 2 over a to the 3rd power. All right, here's another one that looks a little bit complicated, but first of all, let's see if we can do a little simplifying before we get too far into this. I notice I got this big section under the bottom here that is all raised to the 0 power. So that means that this whole part just becomes 1. So this is 1 instead of all of that. So now I can just do 1 times 2 is 2. And then I have x to the 4th, y to the 2nd on the bottom. And on the top I have x squared y to the 3rd. Alright, so if I look at this, the y values, I have a smaller y value on the bottom than I do the top, so I'm going to move that up and subtract it from the 3. And I have a smaller x value on the top than I do on the bottom, so I'm going to subtract that 2 off the top, bring it down and subtract it from the bottom. So 3 minus 2 on our y value would leave us with y to the 1st. Then on the bottom we had 2, and x to the 4th minus 3rd, which is x to the 2nd. So y to the 1st over 2 x to the 2nd. I forgot to put the x in there. And that would be our final answer. So hopefully, as you do a few of these, they'll make sense, but that's one of the ones on your worksheet. Okay, good luck with that worksheet. Again, it was All Exponents Review worksheet. If you're doing this at home, you should be able to print it off of the Today button page, or you should have a link to it so you can take care of that. So, thank you very much.